Hey guys, welcome. In this video series, I'm going to be showing you how to create a top-down shooter in Godot. This tutorial is for complete beginners. So some notes. Now it's for Godot beginners, so those who are new to Godot, and also new to game development. But it is not for beginner programmers. So you already have to know the basics of programming, such as while loops, for loops, functions, things like that. Now we're going to use C#, so you want to know the basics of C#, the syntax and stuff like that. Just the basics. You don't have to be a programming wizard, but you cannot be a brand new programmer because this is not a programming tutorial. This is a beginning game development tutorial using Godot. Now, there's a couple reasons why I use C# and not GD script. The main one is because C# is widely used everywhere, while GD script is only used in Godot. So do you really want to practice a language where you're only going to be able to use it in Godot, or would you rather practice using a language that you're very likely to use at your job or somewhere else, you know? I don't want to learn a Godot specific language. And plus, C# is really nice. You know, it's a really good language, very easy to use, very friendly, so I don't see a reason not to use it. I understand that GD script has its own positives, and I've tried it. I just don't think it's worth it, personally. So anyways, we're going to be using C# for this series. This video series is going to be presented what I like to call casually. So, you know, it might be a little bit longer than my videos usually are, and I'm going to put less preparation effort. I'm still going to prepare. I'm still going to, you know, make a plan before I record the video, but I think I tend to overdo that. And thus I don't enjoy making videos as much. So the main reason why I'm doing this is because I enjoy making videos a lot more like this. And also, some people say that when I kind of just free flow talk about stuff instead of doing a whole bunch of preparation, it's better because I present my thinking process more rather than just the end result. A few notes about the description of the videos. So make sure that you check the description of all these videos because sometimes I'm going to link to other Godot videos that I've created on specific topics that might be relevant to that particular video. Sometimes I'll link to other recommended resources, whether videos or text outside of my own channel. And I'll also, of course, link to the code that I show you in the video. And last but not least, I'm going to link you to some slides because I'll make slides for every tutorial. And while you won't see them in the video, I'll have a link to them. And this is for two reasons. One, some people prefer written material, so slides are written. And two, you can kind of use the slides as a summary. I often put a summary at the end of the slides. Okay, so now we're going to officially start tutorial 1. In this tutorial, actually in the first few tutorials, I'm going to be throwing a lot at you, especially in the first tutorial, in this tutorial. A lot of concepts, a lot of terms, and this tutorial might end up being pretty long. But don't worry, you don't have to memorize anything that I tell you in this tutorial. Just let it simmer in the back of your mind, and then we're going to go over all of these concepts again and again and again in the next few tutorials. So it'll be a while before I actually expect you to know this stuff, okay? Just keep in mind this might be a long one and there might be a lot in it. So the objective for the first tutorial is just to get a player character that we can move around using the keys and that will always face the mouse. So just movement, essentially. All right, let's first go ahead and launch Godot. So I'm going to assume that you know how to install Godot. It's very easy. Just go to the website, click on download. Make sure you download the one that says mono, okay? That's for C#. And then extract it. And once you extract it, the zip file, go in the folder, and you'll see an executable. Just launch that executable. So when you launch it, this is what you'll see. You have this little message that says you don't have any projects. Would you like to explore example projects? Just go ahead and click cancel. So to create a new Godot project, first you want to create a new folder for it. I'm just going to put it on my desktop. So this folder will have all the files for your project. I'm going to call it tutorial 1. Okay, and then here, click on New Project and choose that folder that you just created, the path to it. So mine is on the desktop. And here, give your project a name. Tutorial 1 is good. Here you can choose a renderer. You don't have to worry about this too much right now. Choose OpenGL ES3, which is newer. You would choose OpenGL ES2 if you want your game to run on an old device that doesn't support OpenGL ES3. So click Create and Edit. So Godot has a 2D scene editor and a 3D scene editor. Right now we're in the 3D. Go ahead and switch to the 2D. Alright, now I gotta quickly go over what scene and nodes are, alright? You don't have to remember this. We'll cover this a lot more in future tutorials. So I got some slides prepared for this. So a Godot game is just a bunch of scenes. That's what a Godot game consists of. So what's a scene? A scene is basically, it has a bunch of nodes in it and other scenes. So it's kind of a recursive definition. What are nodes? Well, a node is the smallest building block. Godot gives you a bunch of nodes and you use those nodes to create your game. Pretty simple. So node is the smallest building block, and you can think of a scene as a group or collection of other nodes and scenes. So only a couple of notes, only one scene can be active at a time. So only one scene can be drawn in a sense on your window. But you can change the active scene. So if you have multiple scenes, you can change which one is active, but you can only have one active at any time. And you can attach scripts to nodes to give them additional behavior. So each node that Godot comes with already has some stuff you can use, but to give them additional behavior, you attach scripts to them. So you can think that the scripts kind of extend the nodes. Here's a little visual. So a Godot game consists of a bunch of scenes. A scene can have a bunch of nodes or other scenes, and they can be nested. And I show here that I have a script attached to this node and another script attached to this node. So we're giving these two nodes some additional behavior. All right, so now this is your scene editor, right? This is an empty, unsaved scene. So, and we have nothing in it, right? And what you're seeing at this cross section right here is basically your global coordinates. We'll come back to this at some point. But this is your coordinates, right? That's 0, 0, positive x this way, positive y that way. Now this tab shows what's in your scene in a hierarchical. I don't know if hierarchical is a word, but I'm going to use it. So this scene tab will show your scene contents in a hierarchical view, while this scene editor will show it in a graphical view. You'll see shortly what I mean. All right, so we got an empty scene here by default. Let's add a node. So to add a node, in the scene tab, click this little plus button, and that'll bring up this window. Here, you can see all of the nodes that Godot comes with. So every node in Godot, right, is a class, basically. And when you add one of them in a scene, you're adding an instance of that class, essentially. So the nice thing about this window is that it shows you the nodes in the same class hierarchy. So let me give you a concrete example. So for example, here, right, the animated sprite node inherits from node 2D, which inherits from canvas item. So this arrangement is basically how the class hierarchy is arranged. Just keep that in mind. So you can search nodes here. This is useful for quickly adding. So let's go ahead and search for a node 2D. Node 2D is just a generic node, and I usually make this the parent node of every scene, which I should note at this time that a scene can only have one and only one parent node, but you can have as many nested children as you want. So let's go ahead and add a node 2D as the root node of our scene. So notice that you see a node 2D here, right? We've added it. And if you mouse over it, you'll see that what pops up is the type. It says the type is a node 2D. So that's because what you're seeing here, the non-pop-up, is the name, right? So I could name this root. I could just name it root. And in fact, I will for now. So I have a root node, I'm calling it root, and its type is node 2D. Let's go ahead and add a child. So you can right click, add child, or you can use Control A when you have the root node selected. So also I want to mention, if you select the root node, so click it, you'll notice that this little cross gets highlighted. So pay attention right here, watch. When I unselect it, right, and now when I select it. So that's because this root node is located right here, so at position 0, 0, right? Because this is position 0, 0. If you move it around, you'll see that it changes. So let's go ahead. If you want to move a node, there's a couple ways. One way is you can go to the Inspector tab, which shows all the properties for that node. And if you go to the Transform category, the position is here. So I can make the position 100. Watch what happens to this cross. There you go. It goes to 100, 100. So the position for the root node is relative to this, basically, that coordinate right there. We'll go into more detail about positions and rotations and transformations, okay? All right, let's make this back to 0, 0 for its position. All right, so let's go ahead and add a child node to this guy, and I'm gonna add a sprite. So if you mouse over this, it gives you a description. Here, the description is not too useful, but basically a sprite node can hold a picture. It shows a picture at its location. All right, so let's name this graphics. And again, when I mouse over it, it'll tell me that the type is sprite. So remember that each node in your scene hierarchy or your node hierarchy, right over here, they have a name, which is what you see right now, and they have a type, which is what you see when you hover over them. When you select them, right, you'll notice that the Inspector tab shows you the properties for that selected node. Now remember, each one of these nodes here, they're actually an instance of a class, right? So this is an instance of a sprite class. And a class, as you know, has properties, sometimes called attributes. So you can graphically set those properties over here. One of the properties that the sprite node has is called texture, which is basically what image you want the sprite to show. So you can set this to whatever you want. Now, when you create a new Godot project, which is what we just did, if you go ahead and open up your folder that you created this stuff in, so let me go do that right now. Here it is. So this is our folder. You'll notice that there's a bunch of stuff, right, that you get by default. One of the things that you get is a picture called icon.png right there. You'll also see a view of what's in your project by looking at this File System tab. So this shows you the same thing we just saw in the Explorer. You'll see that the icon.png is right here. If you drag that icon.png to the texture property of the graphic or the sprite node, right? So I'm dragging it right here. You'll notice that that sets the image that the sprite should show. So it's right there. Now, let me show you a little bit, right? Every node has a position, and its position is relative to its parent. So the root node we know is sitting right here, right? And we know that graphics is a child of root, and its position is going to be relative to the root. So let's set the position of the graphics. Let's go to its transform category and position property. We'll do 100 on the x-axis, so it moves that way, and then 100 on the y-axis. Then it moves this way. Now, so this is 100, 100 relative to here. But if the root was somewhere else, watch what happens. So let's move the root. Let's move the root to position 50, 50. So watch 50 along the x and 50 along the y. You notice that the position of the root is 50, 50 relative to its parent. And since it's the root, its parent is really the global coordinates right here. So that's 50, 50. And then the sprite, which we called graphics, we named it graphics. The sprite node is 100, 100 relative to the root, to its parent. So that's the key thing to remember, that a child node is positioned and its rotation and position is relative to its parent. And I'll show you that even more, why not? So if we take the root and we rotate it, right? So let's rotate it 15 degrees. See? All right, we're gonna make the root position 0, 0 now. So one little hint here, you'll notice that over the position property, there's this little arrow. If you click it, that just resets it to what it was by default, so which was 0. So there we go. Okay, so we got an unsaved scene here. Just press Control S or go to Scene and then Save. And here you're gonna just pick where to save it. Whenever you see this res, R-E-S, :// that basically means the root of your project folder, right? So remember, my project folder is in the desktop, so it's going to be the root of that folder. So we're going to be in our root of our folder, and what am I going to call this scene? So scenes have a .tscn extension. Just keep that in the back of your mind. I'm going to call this player, because this is going to be a player. So now it shows that the name of this scene is player, and what does it have inside it? Well, here we can see it graphically, and here in the scene tab, we can see it hierarchically. So we got as a root, we got a node here that is the root, and the name that we gave it is root, and the type, if I mouse over it, is node 2D. It has a child, which we named graphics, and its type is sprite. For the sprite node, I set its texture property to icon.png. So that's technically res/icon.png. So res means at the root of our folder, and then icon.png, so the path to that image. And again, the texture property of the sprite basically determines what image it shows. Okay, now let's add a little behavior to our player, right? To this player scene. So the way that I'm going to do that is I'm going to attach a script to the root node. So really, scripts give a node behavior, right? But if you attach a script to your root node, you can kind of think that you're giving your entire scene behavior. So that's how I think of it. So to your root node, go ahead and you can either right-click and choose Attach Script, or there's a little shortcut right here, and you can click that. So I'm going to attach a new script. This is a bunch of options for the new script. For the language, make sure that you use C#. Inherits, leave that for now. Template, leave that. The path is where the script will be saved. So again, res means the root of your project folder, and then it's going to be called player.cs. That sounds reasonable to me. Hit create. That will create the file and open it up in its own code editor. I don't like using this code editor. I like using VS Code to do all of my editing. So I'm going to go ahead and switch back from the script section to the 2D scene editor. I like seeing my scene like this. I open up Visual Studio Code to do all of my script editing. So let me close what I had before. Don't pay attention to this. So to open up your project in VS Code, just take your folder, your project folder, and drag it in. So like this, just drag it in. That'll do some stuff in the background, and it opens up. I should note, to make this work, you need to download a few extensions for VS Code. Downloading extensions for VS Code is extremely easy. I'll show you that right now too. Click this extensions thing, and then over here you're going to search for it. So here you're seeing what I have installed, but you can search for yours. So first you want the C# extension, okay? Make sure you download the one by Microsoft. So when you click it, right, you're just going to have an install button or a download or something like that. Just click that. I don't see that because I already have it installed. Now, also you want to get C# tools for Godot. So that's C# tools for Godot. And that one is by Ignacio Roldan. I don't know how to say his name. So download that. And then also download Mono Debug. That one is by Microsoft as well. So you need those 3 extensions, and you can work very well on Godot projects using VS Code. All right. So we got our project open in VS Code. We can script it. Now remember, we saved our script as player.cs. It generates all of this template code. Go ahead and get rid of all of it because I want to start from scratch. All right, so notice that it basically created a class for our script and it named it player, the same as our file. It inherits from whatever, all right? From node 2D. So every node in Godot has a few methods, right? A few methods that get called at certain times. One of those methods is called underscore process. The underscore process method gets called executed every frame. So now let's quickly take a diversion and go through a game's main loop. Every game has a main loop. The main loop is exactly what it sounds like. It's a loop and it keeps on doing its thing over and over. What does it do? Well, remember that a game has a bunch of objects, right? So it has some players, maybe some some players, some zombies, some trees. Notice that each of these things have like some properties like health, position, right? And so what happens is first the game basically tells all of these objects, so it iterates through each one of these objects and calls its underscore process, right? So it calls every object's underscore process, and the object will do something. It might move, it might decrease its health, whatever, right? It does something. And then after it has called the underscore process method of all the objects, it will draw them. So if any objects have moved since the last time, then they're going to be drawn at a different location. So that's what a game loop does, right? So let me just use this place to show you a game loop real quick. So a game loop is something like this. So while true, this is pseudocode, okay? This is because I want to write this quick. So while true, for each object in the game, right, you're simply going to call objects process method. And in the process method, you're going to tell it the time since the last time process was called. So this is called the delta time. Delta time means how much time passed since the last time your process was called, okay? So you call every object's process, and then after that, you're gonna draw all objects. Take a look at that. That's what a game loop always does, all right? It calls the process method of every single object in the world, and then it draws them. Calls the process method of every single object in the world, draws them again and again and again. So by implementing the process method, you're basically determining what your node does when it's his turn in the frame, okay? So that's what's called a frame. A frame is basically when all of the objects process method gets called and then things get drawn. That's one frame. When it happens again, that's a second frame. All right, you might hear that term. So let's go ahead and implement the process method for this guy. So I'm going to override it because it's an inherited method. So it's called process. I don't want to call the base. All right, what do we want to do during the process method for this node, right? So for our player node. Well, I want him to move if the keyboard keys are pressed. So let me write a little bit of code to do that, and then I'll explain it for you. All right, so here's the code that I just wrote, and I also zoomed in a little, increased my font so you'll have an easier time seeing. All right, so first we create a vector2, which is just a two-dimensional vector, and we initialize it to have an x component and a y component of 0. And this is the vector that we're going to move by. So initially we're going to say we're going to move by nothing. So we're going to move nothing in the x direction and nothing in the y direction, right? Now here I'm saying that if the up key was pressed, then basically set the y component of our move vector to -100, which essentially means move 100 up, because remember that the y-axis points downwards, so -100 means up, okay? So to basically ask Godot to query when a key is pressed in Godot, you use the input classes isKeyPressed method, and then all the keys are in this key list enum. So there's up, down, left, right, etc. The only little quirk is that you have to cast this enum to an int, all right? Because the isKeyPressed method expects an int. That's just some little thing you got to remember. So I'm pretty sure you get this code nice and simple, right? So we're basically going to go through these if statements, and then at the very end, we're going to add this move vector to our position. So that's what will move us. So let's say that none of the keys are pressed, right? So remember that this process loop, this process method is running every frame, right? So let's say in a particular frame it's running, no key was pressed, right? So the move vector gets initialized to 0, 0, and then this if doesn't get executed, this one doesn't get executed, this one doesn't get executed, and this one doesn't get executed because there's no key that was pressed this frame. So then what do we add to our position? We add the vector 0, 0, which means, you know, we don't increment our x component of our position or the y component of our position. All right, so we don't move at all, in other words. Now, what if during another frame, you know, let's say that the up key was pressed. If the up key was pressed, well, we set the y component of the move vector to -100, which means that when we add this move vector, we're adding -100 in the y to our position. All right, so hopefully that makes sense. All right, but we can make this a little neater. So this was just to show you the basically basics, right? But we can make this neater. So remember that I told you that this delta tells you the time since the last time this process method was called, right? So you want to use this delta anytime you're doing timing stuff, because the number of times that this process method gets called on your object, the number of times it gets called per second varies. It depends on how fast the computer is. You don't want to move faster. You don't want your player to move faster on a faster running computer than on a slower running computer, right? You want your player to move at the same speed regardless of you know, what computer the game is running in. So there's a trick to do that. First of all, you know, determine your speed, you know, in pixels per second. So let's say I want to move this guy at 100 pixels per second. All right. So actually, before I do that, let me just show you that this basic code is working, right? So we're going to save it. You can click this little button over here to play the scene, which means launch the scene, or you can, you know, press F6. So that'll build it, and then here it is. All right, so let me use the arrow keys. I'm going to press the arrow key down. So there. So you'll notice that he moves very fast. He's not moving at 100 pixels per second, right? He's moving 100 pixels basically every frame where a key is pressed, essentially, okay? So let's go ahead and exit this, and let's make him move like, I guess, 50 pixels per second, so really slow. So we've determined our speed. Go ahead and store that. Store that. So speed is going to be 50, and I'm going to put a comment here, pixels per second. All right, so that's our speed. Okay, now the amount that we're going to move by depends on how much time has elapsed since the last time process was called. So on a fast computer, delta will be small. So a very small amount of time will have passed since the last call, since the last frame. Therefore, this delta is going to make your value smaller. Let me show you via code first. So we're going to say float move amount. Move amount is going to be speed times delta. Okay, so let's say that 1 second, so delta is 1, which means 1 second has passed by since the last frame, since the last time process was called. So delta is 1. 1 times 50 is just 50. So if process is being called once per second, then every single time we're moving 50 pixels. That is 50 pixels per second. Let's say your computer is a little bit faster, so that only half a second passes between frames. So in other words, you're doing 2 frames instead of 1 frame per second. So delta is half. Half times 50 is 25. So you're moving 25 pixels every frame, but you're doing 2 frames per second, so you're still moving 50 pixels per second. So you see how that accounts for it? All right. So we know how much we should move in this frame based on how much time has passed since the last frame, okay? Now let's move by that instead of by this random 100. So here we're going to still move in the negative y, but we're going to move by move amount. Here we're going to do move amount. So this is pretty straightforward. I'm just going to replace that hard-coded 100. All right, let's go ahead and see how this works. You see that? Much better. Now we're going to run 50 pixels per second, and this will always be 50 pixels per second whether my computer is super fast. So let's say my computer was running at like 500 frames per second. It doesn't matter because it will always be 50 pixels per second the movement. Even if my computer was really slow and it was going 1 frame per second, I'd still be moving 50 pixels per second. So that's how you use delta to make movement consistent amongst different hardware, essentially. Okay, so that's one portion of our objective. The other was to always face the mouse. So let me label this move in response to arrow keys, right? Also, every process, so every frame, I want the player to constantly move towards the mouse. That's why I put the code here. So face the mouse. All right, how do you do that? Let me type up the code and then explain it. All right, so here's the code, very simple. What we do is we get the global position of the mouse. We subtract the global position of the player. So that gives us a vector that goes from the player to the mouse. And we just get the angle of that vector. And then we set the rotation of the player to that angle. In future videos, we're going to go a lot more through the math of these things, but right now, if you kind of get it, that's good enough. So let's go ahead and one more change I have to make here is I want this graphics node, this sprite, I want to set his position to 0, 0. So he's right on his parent's root, I guess. All right. So let's go ahead and run this scene again. So play the scene. Now let's see if we're always facing the mouse. There you go. You see that? So yeah, I guess what it's considering as his facing angle is his right. So you see he's always rotating to face my mouse. Okay, so I decided to quickly just show you a graphic of setting the angle, right? So if the player position is here and the mouse position is here, right? If I take the mouse position and I subtract the player position, then what I'm getting is this vector right here, right? The vector that goes from the player to the mouse, because that's how vector subtraction works. So all I need to do is get the angle of this vector relative to the positive x-axis. So this angle right here. And I do that by calling the angle property of that vector. So let me show you the code again. So here, all I'm doing is I'm taking the mouse position, subtracting the player position to get that vector, and then I'm getting the angle that that vector makes with the positive x-axis. So in graphical format, here's the positive x-axis, here's the player position, here's the mouse position, here's that vector that I get by subtracting mouse position. By doing my mouse position minus player position, I get this vector. Then I get the angle that that vector makes with the positive x-axis. And I set the rotation value of the player to that, so the player faces the mouse. Simple. Okay, and there's one little last cool thing I want to do before ending this. I want our player to use a different graphic, so a better graphic than the that little icon that we used. So what I'm going to do is I'm going to go find an image, which I already did. I find a new image of a nice, a nice graphic. Go ahead and put it anywhere in your root project folder, anywhere. So I usually create a subfolder in my project. I call it images, and then I put all my images in there. So I'm gonna copy my image in there. So I found this player.png online for free, and I put it there. And you'll notice that I have in my file system tab, I have my images folder, and then I have player.png. So remember, we're going to select the sprite node and its texture property. We're going to replace that little icon, right? So I'm going to drag player.png right there. Watch what happens. There we go. Now he looks like a player. Let's play the scene. And let's move him down. So that already looks a lot better. So we got a little player moving around in response to the keyboard keys and facing the mouse. Let's make him a little bit faster. So go to our code, make the speed 150 pixels per second, run it again. And so there you go, he's much faster. Okay, that's it for this tutorial. Now again, I'm gonna have a ton of stuff in the description of all of these, all of the videos in this series, such as, for example, for this one, I'm gonna put the code up. I'm gonna put slides that I've been making up there for those of you who want a summary or you just want to read to refresh your memory of what you learned. And the slides, I highly recommend you take a look at them because they're a lot shorter than the video. Like this video was, you know, I don't know, maybe 40 minutes long. That's because I had to throw a lot of concepts at you in the beginning. But the slides are going to be a lot shorter because they're kind of like a summary, you know, a little reference. You can almost think of them. So that's it for this first tutorial. We're going to improve this top-down shooting game significantly by the time we get to like, you know, maybe like our 8th or 10th tutorial. So thanks for watching. Bye-bye.